Good evening, everyone. I hope you are all fine. Today, I'm going to start with you talking about a quick revision of what we have did go through our lectures. All the course resources, you will find them on Canvas and also on the YouTube channel as always. Today, I would like to go through classwork 1 and classwork 2 as an overview of our course. Your final exam will be exactly, will cover all the aspects and the main points that we did go through our course. Remember, we have 15 ILOs that should be satisfied and found at the final exam. First of them, the knowledge and understanding of all types of functions according to our DMD, knowledge and evaluation of limits, the understanding and knowledge of derivative main concepts and formula, going through the derivative using the first principle from the concept of the limits and the rate of change of the dependent variable with respect to the independent variables, going through explicit and implicit function derivatives, the concepts of the chain theory or the chain rule or the parametric derivatives also will be covered in the final exam. Remember that the application of derivative going through L'Hopital method, Taylor, Maclaurin, and then the investigation of various types of functions, going through the various types of asymptotes, the vertical, the inclined, or the horizontal, and to find the various critical points by identifying these types of sketch of this function. It's all found in the part of the application of functions. Also, within 6, we will cover the partial derivatives of or the functions in several variables and the concept related to partial derivatives. Once you go to 8, we will go to the antiderivative, going through integration with the main laws that's used in integration in various functions, going and covering the integration by parts, integration by substitutions, when to use substitutions, what's the suitable substitutions that can be used in your integrations. All of this you will find it in the final exam. As I stated plenty of times, your final exam will cover every aspect that we did go through our model, starting from the first lecture till the end of our course. Also, you will have a part on the application of different integration, going through the mean value theorem, the area evaluation, numerical integration once you can't find the analytic forms for the different integration, through the trapezoidal or Simpson rules, which is the most famous rules in numerical integration. Also, whether we will cover in this video the complex numbers, Euler and exponential forms. We already did that in classwork 2, and you will find them again once more in the final exam. Last but not least, going through the first order differential equations, solutions using separation variables, homogeneous, linear, exact, and reducible to exact equations for first order differential equations. And also we will have enough knowledge and plenty of applications on higher order differential equations using the undetermined coefficient method or the inverse coefficient method and the relation of parameters. Of course, in the final exam, as exactly like in the first 2 exams, the first 2 tests, classwork 1 and classwork 2, you will be allowed to have just only one paper double-sided with the main laws. Don't try problems in it all. Use sheet paper that's allowed with you in the final exam. I thought it's better to cover the first, the last ILO actually by the beginning of this lecture or of this revision, instead of leaving until the end of our lectures, and by the end you will get, maybe you will use your attention a little bit. And the second exam, you have been asked to solve these ordinary differential equations, and you have been given 2 of them. One of them which states y plus y dash of x plus y plus x e to the power of x squared times y. Once you see these problems, you have to first to decide, is it an ordinary differential equation or a higher order differential equation? So it's for the first one, it's an ordinary differential equation. The main problem or the main choice or the main difficulty in this class of problems is to identify the suitable method used to deal with such problems. I personally would recommend that you go through the bits related to the ODEs. I've given you a lot of lectures about how to deal with ordinary differential equations. Also, I made a couple of lectures which did go through a quick revision about how to deal with them. This problem came to you in your in the previous test, but it's very simple. All you have to do is to get y plus y dash of x, which is gonna equal to start expanding this bracket, so it's gonna be y plus x times y times e to the power of x squared. Once you expand this bracket, you will remark that you can cancel both y from the left-hand side and the right-hand side, and you will end up having dy by dx, which is going to equal to x times y times e to the power of x squared. This problem, it doesn't contain any addition or subtraction between various variables. Instead, you have multiplication and division between the various variables. So it's really very simple, is to try to separate all the x variables with dx and all the y variables with dy. So simply rearrange your problem, so you will end up having dy by y. I've just moved y from the right-hand side to the left-hand side, and vice versa, multiply both sides in dx. So you should have x times e to the power of x squared, and you will have this. Once you reach this point, you will find you have a function in y times dy, and you will have on the other side a function in x times dx. All I have to do is to integrate both sides, each side with respect to its variable. So all I'm going to do is to integrate the right-hand side with respect to dx, while integrating the left-hand side with respect to dy. And this is using integration, as you know. It's going to be len y, and for that part, I will need to multiply by 2.5, and you will end up having half times e to the power of x squared plus c. Already, you know that this is integrable function. Once the condition is valid, the derivative of the power already exists, which is 2x. So in integration, you will have this. This is for the first problem. If we went to the second problem, which will appear to you, it's not going to be easy to find a separation of variables technique. This problem will be solved by separation of variables. The other problem, it's not going to work this way, because the existence of the negative sign between the y and the x. Okay, hold on. Let's try if it's going to work as a homogeneous. So let's try to get the check. I'm going to put it in this form: y dash 2 of y dash, which will equal to, I'm going to divide the whole equation on x squared, or simply start to replace every x by x lambda x, and every y by y lambda y on this form first. So I think it will work. See, it's going to be 2 of lambda x times lambda y times y dash, which is going to equal to lambda squared times y squared minus lambda squared times x squared. If you remark, we can cancel these values all together, so the problem will regain to its main shape. 2 of xy, y dash will equal to y squared minus x squared, so it can be solved as a homogeneous or ordinary differential equation. That's suitable to see y over x as we spoke previously in this part. So I'm thinking about dividing the whole equation by x squared. So I will start writing 2xy y dash, which equal to y squared minus x squared. Let's divide the whole equation by x squared. If we divide the whole equation by x squared, you will find 2 of a y over x times y dash, which is going to equal to y over x to the power of 2 minus 1. And on this form, we can start thinking about the assumption of letting y over x equal to u, and this way y will equal to u times, u times x, u times x, and this way y dash will equal u dash x plus u. Start getting this value and start substituting in this problem. So you will end up having 2 of u times u dash of x plus u. That's gonna equal to, okay, let's put it this way, it's gonna equal to u2 minus 1. Now let's start rearrange our problem. So you will have 2 of u times x u dash plus 2 u squared. Simply I multiply 2u times these two parts, and it's going to equal to, on the right hand side, u squared minus 1. Let's start getting u's on one side and the rest of the values on the other side. So simply you will have now 2u times x times du by dx, and this is going to divide on the other side negative 1 minus of a u squared, this form. Start rearranging, moving dx over x to the right hand side and getting 1 plus 1 u squared on the left hand side. So simply it can be rewritten as 2u du divided by 1 plus u squared, and it's going to equal to the negative sign of dx divided by x. This is the main problem that we are facing at the time being. We mark dx equivalent as a denominator times x, which is a denominator, getting 1 plus u squared to the left hand side. So it's going to be 2u du over 1 plus u squared. This form is integrable, easily to be integrable. Now we make a separation of variables. So simply I'm going to integrate these two sides. Each one of them was respect to the main variable that exists in it. So integrating this function, you have the denominator. Denominator is the derivative of the denominator, and the denominator power is 1. So simply it's going to be n over 1 plus u squared. On the other side, you will have negative of ln x plus a constant. I will remove this constant and let it be ln a, as we have taken this plenty of times previously. So you will have ln of 1 plus u squared, which will equal to ln a over x. Replacing the c by ln a, then simplifying this part, take ln out of your equation once more. So you will have 1 plus u squared equal a over x. Start replacing x by the value of y over x. So it's simply y over x to the power of 2 plus 1, which is going to equal to a over x. And this will stand for the general solution for this problem, as you can see. So now, and once more, you can see that we have succeeded in dealing with such a problem in this way. This is for the first part, or question number 9. Please, if you have any problem going through all of this, please do try to review your main verbs that deals with ODEs and higher order differential equations. Once more, let's go to the next slide or the next question. Here is asking you to solve y dash plus y equals sine x, and then you will have an equation or a question about a direct application of the ordinary differential equation and RL circuit. Okay, and we are taking actually some applications on circuits. So please, I would recommend that you go through these problems. It's very, very simple. I have a whole record about this application. Please go through them. At least one of them will be found in the final exam. So it would be really very nice to go through them. Let's see the first question. Okay, he's asking you to solve the given equation, which is very, very simple. Y dash plus y, which equal to sine x. It's an ODE differential equation. It's an ordinary differential equation. And as you can see, it's a first order differential equation. All I have to do is to figure out how to solve this problem easily. Are you a separation of variables? Is it going to work? No. Is it going to be a homogeneous? Although it's really very close to the form of a linear ordinary differential equation, remember, you will have y dash plus some sort of a function x times y, which equal q of x. Once you put your function on this form, the solution will be in two steps. The first of them getting to u, which equal to e to the power of bx dx. As you know, all I have to do, once you get your integrating factor, step number 2 can be easily done, which is simply gonna be that y is gonna equal to u to the power of negative minus 1, integrate u times q of x dx plus c to the power of negative minus 1. And this way you will be able to solve this linear ODE. All I have to do is to get mu. Here we have b of x equal 1, y q of x, which is simply sine x, getting the integrating factor, which is u, that's going to be e, integrate b of x, which is 1 with respect to x, it's going to be e to the power of x. I have the integrating factor. The second step is to get y as the general solution, which is going to be mu minus 1 integrate mu times q of x dx plus c mu minus 1. Simply, it's going to be e to the power of negative x integrate e bar x times sine of x dx plus c times e to the power of negative x. And the problem for the time being, in order to get the general solution, is simply to find the integration of this problem. And this is really very simple. All I have to do is to find an integration for the integration of e bar x times sine x, which is the third part of an integration by worst certain case. So I'm going to go like this, stating that I equal integrate e power x, which is going to e power x, then differentiate the part of sine x, minus integrate, that's e power x, differentiating sine x, you will end up having cosine x times dx. Start once more integrating this part, you will have e power x times sine x minus, integrate once more e power x times cosine of x, then minus, and you will have to start integrating once more the function e power x times the derivative of cosine x, which is going to be negative sine x dx, But remember that for this, you will have negative, and you have negative sign, which is the derivative of cosine x. And this way, the sign will be positive. Now, it's a good idea to change e power x sine x to be actually r. So, in this 4, we have now I, which equal to e power x times sine x minus e power x times cosine x plus over. And I'm sorry, my negative times positive, which is going to be negative. I will start moving I from the right hand side to the left hand side, and this will make you see I like this: e power x times sine of x, then minus e power x cosine x, all of it divided by 2, and voila, you got the general solution, which is simply gonna be e power x times e power x, which is gonna be 1. You will have sine x minus cosine x divided by 2 plus some constant in e to the power of negative x. This is the final solution. The linear ODEs is one of the most important and the easiest problems that you will ever see. The shape is very, very simple. To pick the solution is very simple. Just apply it. It's okay that we stuck with the part of integration by parts. It's durable. You already have it. We did go through it plenty of times, so just simply start to get your answer, substitute, and you will have final answer. This is for the part of the ordinary differential equations that we did go through. Once more, you have this problem, which is about an inductor of 2 henries and resistance of 10 ohms. They are connected in series, so here the coil, here the resistance, with an EMV with the power of 100 times 60 T volts. If the current is 0, is giving you the condition to find the particular solution. What is the current at the end of 4.1? First of all, I will start right that L equal to 2, R is going to be 10, and the E, which is going to be 100. Then we already wrote down the ordinary differential equation that we are dealing with, which is simply L times di over dt plus R times I, which is equal to E. Start substituting. As you can see, we have L equal to 2. R is 10, E, which is 100 sine of 60t. Once you start substituting, once more, you will have integration by parts. Please solve this integration by integration by parts. You will end up having, this is going to be the solution of your linear differential equation, and you will find it. You will find more about this in the application bits. Please go through it. You will have one of the applications once more in the final exam. This is the main form. Start to use the condition at t equals 0. Then you will have c equal 24 over 29. This is I of t. You want to find the value of the function or the power, the current at 0.1 second. All you have to do is to replace the t's by 0.1, and you will have di as it's required at this point. This is the major part that came in the crossword 2, dealing with higher order, or I'm sorry, differential equations and the application of differential equations. Please go through it. It's a part, it's a vital part of your final exam. I actually thought I should start with this part, especially that I've already recorded a revision lecture about the derivative, how to go through it in the previous lecture. Give me a second, please. Okay. Now, this is the cover of the final exam. You will find, you don't have to write your name here, but please stick to UHID. You will have to state your UHID in this row. Level 4, subject, engineering mathematics, the date of your exam, you will have 10 questions, each one of them is 10 marks. So a total of 10 marks will be dedicated for for the final exam. Okay, just a second, please. Then a second, I'm sorry. Okay, as I was telling you, in the final exam, or in the previous exam of classwork 1, he asked you to sketch or to give a sketch for the function of y equal 2x plus 6 divided by 2x minus 4, which is very, very trivial. And for question 2, he asked you about the composite functions. Please do review the part of main functions, quadratic functions, or the rational functions, how to graph them, and the other part which is related to the inversion, how to get an inverse of a function, how to form a composite functions. This is also very, very important. I will start quickly by solving the first problem. The first remark that I can remark easily going through this problem, if we take 2 as a common from the denominator, we will have x plus 3. And if we also take 2 as a common from the denominator, we will have 2 of x minus 2, which is simply can be cancelled out both together, and you will end up having to deal with this problem, which is x plus 3 divided by x minus 2. The most suitable way to deal with this problem, remember, you will have to put it on the normal form, which is very, very simple. All I have to do is to put it on the form y minus b equals sum k divided by x minus a. Depend on the a and the b, you will be able to find your vertical asymptote, horizontal asymptote, writing your denominators, the domain and range is going to be very, very simple. First to start, I will have to put it this way, x minus 2, and this is going to be x minus 2 plus 3, then plus 2, and this will deliver the form x minus 2 plus 5 divided by x minus 2, and simply this is going to be y, which is going to equal to 1 plus 5 divided by x minus 2 in this form. Try to rearrange your form as fast as possible. So it's going to be y minus 1, it's going to equal to 5 divided by x minus 2. Once you put it on this form, it's going to be really a piece of cake in order to, if you like, to get a sketch for this function. I will go for x at positive 2, this is 2, this way, and at y equal 1, this is 1. And as you can see, we have the denominator is positive, so I will simply try to draw my function in the first and in the third quartils. Now I can simply write the domain. The domain is going to be simply x belongs to R except at 2. And the range also will be really, very simple. Y belongs to all the real numbers except at positive 1. And this way you will have your marks, all of them accredited for you. And it's really, very simple questions. You are subject to such questions in the final exam. Go through quadratic functions, go through rational functions, start to imagine if we make this denominator to the power of 2, what the effect actually on this sketch or this function, and try to figure out all of this. You will find the solutions very, very easy. For the other problem, he's asking you to get f composite g of x or as g composite of f. This question is very, very, very simple. All I have to do is to get an f function for g of x, and that's gonna be f of x, which is 3 of an x to the power 4 plus 4. Replace every x by g of x, which is simply cosine x, and you will have 3 of a cosine square x plus 4. In a similar manner, try to get g composite f as a function in x, and this way we will get first g of x, which is cosine, and insert f of x in the angle, so it will come up to a cosine of the f of x function, which is simply 3x squared plus 4. As you can see, it's very obvious that f composite g, it's not going to equal to g composite f composite g, it's not going to equal to g composite f of x. And this is done this way. I hope it's very clear for you. For this modeling grading, I've given 4 marks for the first part, another 4 for the second, and 2 marks for identifying this result. Any problems related to this part, please do go and review the part that deals with the functions, that deals with the main functions and the application of the composite functions. Also, one of the vital parts that we did deal with in this part is how to treat some proofs in trigonometry. This is one of the famous problems where we have a couple of problems like that. You want you to just simply prove that the cosine of 2 times minus 1x will equal to 1 minus x squared by 1 plus x squared. This is very simple. All I have to do is to start from one of the sides and end up to the other side. I will start with the cosine of 2 over tan minus 1x. Actually, it's very simple. Just to consider that tan minus 1x will equal to 1. And this will evolve that x equal to tan 1. Start dealing with the right angle triangle on this board. This is the right angle triangle that we are seeking. You have the angle, which is y, and the value of the tangent or tan, which is equal to x. So I will consider this side to be x and that side equal to 1. This y, the hypotenuse, is going to be x squared plus 1. Now, all the triangle sides are already known. So starting from the left hand side, instead of dealing with this function, I will deal with cosine of a 2y. Wait, just replace tan minus 1x by 1. But unfortunately, this triangle will give you results or the values of cosine or sine in terms of y. But I have here cosine 2y. Okay, let's replace cosine 2y using one of the laws of the trigonometry, which states that cosine 2 cosine squared y minus 1, for example. And that way, I will be able to use this triangle in order to make my substitutions. This is going to that this value is going to equal to 2. Start opening a bracket to the power of 2, and this is minus 1. Cosine y simply, which is 1 over the root of the square root of x squared plus 1. Second step, it's going to lead to 2 times 1 divided by x squared plus 1, okay, minus 1. Simple simplification in this form, it's going to lead up to x squared plus 1. I will have 2 minus x squared plus 1. And simply, as you can see, it will be 1 minus x squared divided by 1 plus x squared, which exactly equal to the right hand side. 1 plus x squared, 1 minus x squared equal to the right and the sine. So you succeeded in proving the function that you, or the relation that's required to be proved. I'll start from here. Please do review this part. We have a couple of wonderful problems that's dealing with the triangles, the derivatives or the relations related to this part of trigonometry. Now let's see the coming problem, which is the fourth problem. Oh, this problem really solved in the bit that I've raised to you earlier this morning, and I've had many comments about this problem. If you want to solve it, first of all, let's put the rule. Let's put the rule this way. If we need to solve an exponential function, start thinking about going through a logarithmic analysis in order to be able to solve an exponential function and vice versa. Let's start with this problem. Okay. First of all, I will try to isolate the exponential part. So instead of having 4 times e to the power of 2x plus c equal 8, once more I will divide the whole equation over 4. So it's going to be e to the power of 2x plus 3, which is going to equal to 2. Simply take len for both sides. Once you take len for both sides, you will end up having len e to the power of 2x plus 3, which equal to len 2. We will have 2x plus 3 equal to len 2, and this will deliver 2x equal to len 2 minus 3. Start dividing on 2, and you will end up having x equal len 2 minus 3 divided by 2. Most of the mistakes that happened in the previous exam is just starting your analysis from this step and take, then you will be confused about how to deal with the problem. There is another solution for such a problem, but you will have to respect the how to deal with the logarithmic function relations that we really did go through. We can